Welcome back to the radio room. We're back looking at the FT101EE. Last part, which was part one, I was talking about reasons I thought that the bias current was down, or I couldn't get it high enough. That had to do with the voltage divider I was suspecting in the regulator board for the bias. I mentioned I was going to replace that resistor and check the other ones. I have checked the other ones, and I've changed that resistor. The one that was the 10K resistor that was reading about 21.3 K ohms, if I remember correctly. So we're ready to test it. Right now you're just looking at the top of the radio. Right here is the adjustment for the bias. That's what we're going to be setting the bias with. Right now I have it turned all the way down, which is fully counterclockwise, before we do this test. And then once, if the current comes up to 60 milliamps and we can get it to there, we'll measure the voltage difference between receive and transmit. I'm hoping that once we have the IC current set at 60 milliamps, or pretty close to 60 milliamps, that we will have about negative 50 volts in transmit going to the grid, which we can measure from here. Basically, coming off the wiper of this potentiometer goes basically straight to the grids, minus a couple of resistors. So it might be we're looking for a goal of about negative 50, if I remember correctly, from the tube voltages. Yes, negative 50 is what it should be at the tube. So I'm going to expect this to be somewhere around between negative 50 and negative 55 volts, because there are two resistors and that inductor between that wiper and the grids. So we'll test that as well. I've already got the radio turned on, and I have the heaters. They've been going for a few minutes now. So basically the test is here, see if we can get some needle deflection and get the needle to point at 60 milliamps and have that 60 milliamp idle current. When we're in transmit, I've got the carrier turned all the way down. Radio's kind of rocking around a little bit there. I'm going to go to sideband. You can do this in tune or sideband. I'm going to go, I just got it in upper sideband right now, and we're going to find out if it's going to get there. Like I said before, normally I could crank this potentiometer fully clockwise and still not hardly get any cathode current. One thing I didn't mention in the other video, the previous video, is when I was checking to see if the metering was wrong, I had actually completely disconnected the metering circuit and the shunt resistor and put an amp meter in line directly between the cathodes and the ground. The reason for doing that was I wanted to take the possibility of the metering being wrong, so I was directly reading the current. And even with this fully clockwise, I could get 0.3 milliamps. If I really cranked the carrier up, which of course was feeding more voltage, relative voltage, it's at the frequency that the driver was putting out, I could bring it up, but I could still not get it without being able to. I couldn't get it up to 60. I could get it higher than that if I really drove it hard, but I think in that point in time it was not acting very well. It was probably an extremely dirty circuit signal. Of course, everything was going into a dummy load at the time. So let's do the test. Let's find out if we can get the current up to 60 milliamps. Basically being able to raise the voltage high enough towards 0 on the bias to actually get the tubes to turn on. So first off, I do have we have the meter right here. I'm going to go ahead and do this right here. So up there in the right hand corner you do have the meter. That way you can watch me as I'm bringing that up, and hopefully this is going to work. So no carrier. You always check your bias, your 60 milliamp bias, with no carrier. I got the carrier turned all the way down. The mic gain is turned all the way down. Basically, this thing shouldn't be transmitting at this point. I got it in a single sideband, so we shouldn't have any RF really coming out of the tubes. We should just be turning them on. So I'll flip the Mach switch, and then I'll start adjusting this to see if we can get the current up. So I'm going to go to, we're in IC on the in the position switch for the meter. So I'm going to do this in a little bit awkward position for me to just look straight at the meter. So that's in the Mach. We have 0 deflection yet. I'm going to start bringing this up. Oh, I'm starting to see the needle move. And right about there should be 60. I'm going to turn this off for a second. Kind of close in on the meter. So if you're looking at the meter there, you can see where it says 0.1, 0.2, 0.3, 0.4, 0.5. That's the grid, or the cathode current that we're measuring. So 0.1 would be 100 milliamps. So if you look at the little lines between 0 and 0.1, each one of those is 10 milliamps. So, or correction, 20 milliamps. So we want to go with the third little line before 0.1. So let's check to make sure that that is where it needs to be. And right on. So we're getting bias current now. So let me go ahead and we're going to check this. If you look at the meter, let me get back over to that. Got the meter sitting there. I have it in the 200 volt range. So we should be able to go off the wiper here and get a voltage on what the bias is sitting at right now. So right now we're sitting at negative 67 volts in receive. That should be pretty close. According to the service manual, that should be negative 63. So like I was saying before, even in the transmit, when I was saying it might be a read slightly higher here, there are some resistors in line after this. So let me go back to here, read that. I'm going to go to transmit just to check the bias, and we dropped to negative 52.8, 52.7, somewhere in there. So that's good. Before, even with this crank all the way clockwise, basically raising that voltage closer to 0 as far as I could only get it to about negative 70. So the tubes were definitely biased off. I think we're in good shape now there. That should make it so that we can set the bias correctly. We can also possibly dip the plate when we're using the tuning. Before, there was no way to check that. Without seeing that grid current, there was no way to dip the plate when you were starting to tune the radio or the output. So real quick, let me kind of move some stuff around here, and we will do an output test, and this might tell us if these tubes are still good. So let me get that, like I said, I'm a little awkward in the desk right here on the workbench here. Let me get some stuff moved around so we can take a look and maybe tune this thing and see if there's any output power. So give me just a moment and we will get to that. Okay, we're back. Got things set up a little bit right now. You're looking at the power meter. I'm going to keep y'all on that one because we're going to take a look to see if we can get any output power out of this thing. I'm on a 40 meter frequency. I want to try and keep this thing in a low frequency, just because I'm not sure exactly how well the tubes are neutralized, and they're less likely to run away and resonate in a lower frequency. So I don't know if y'all can hear the speaker. Turn the volume up a little bit because we need to peak the noise, basically, and it's a little hard to do right now. I'm running into a dummy load, so there's not a lot of static to hear. But I'm going to see if I can peak the noise on the pre-select. That's going to be the first step in tuning the radio. Noise is coming up. Okay, so it went up and it's come back down, so I'm going to see if I can find the peak. It's about right there. I'm going to turn the volume down. Still got the carrier at 0. I'm going to check to make sure we still have our 60 milliamps. We do. Now, I'm going to take the carrier level. I'm in tune, in my mode, by the way. I'm going to take the carrier and I'm going to raise it to about 100 milliamps. We do have that coming up. So let's see here. And we've actually already got some power output, and things aren't exactly peaked right there. So I do have the plate sitting right about the middle of the 40 meter band. So I'm going to, once again, I got about 100 milliamps coming out. I'm going to see if I can dip the plate. I kind of wish I could set this up so you can see the power output and this, but things are a bit crowded on the bench right now. So I'm going to see if I can dip the plate. Okay, and I have got a little bit of a dip there. It's not really pronounced, but I could see the needle moving at that point. So I'm going to increase carrier just a little bit. And at this point in time, I'm going to kind of reset the pre-select, trying to maximize the power output. Okay, I'm actually going to move up to the 200 watt scale. I was on the 20. So we're getting about at least 20 watts out at this point. And that's about the peak on the pre-select. I'm going to give it just a second to let the tubes cool down a little bit, because things still aren't tuned quite right. And that was about 10 watts, about 20... Yeah, it might have been more than that. A little over 20 watts out right there. It's on the 40 meter band. So now I'm going to adjust the loading a little bit, see if I can't peak that power output some. One thing I am going to check real quick. We're still only at about 140 milliamps. So we should be still safe there. We want to keep this below, say, 250, if I remember correctly. When you're in the tuning spot, and I only have the carrier at about, it's less than halfway up. We're going to tune it this way, and then we'll take it and see how far we can get. And I'd like to keep the, we'll see what we can do about maximum output power with 200 milliamps or less. So here I'm going to tune the loading just a little bit, see if I can peak the power up a little bit. Right about there. Now I'm going to see if I can peak the power output by adjusting the plate slightly. And that's pretty close. Go back to loading again. Have that peaked, and I'm just going to check the pre-select just a little bit. Just going back and forth between the plate and the loading a little bit to see if it's maximized. And that's about right there. And this is on a frequency of about 7.2 megahertz. So that's about 30 watts out right there. About 120 milliamps on the cathode. So I'm going to turn the carrier up just a little bit and see what we can get, and still stay below, say, 200 milliamps. Okay, 200 milliamps out. That's where I just stopped it at, and that gets us right about, let me look in the camera here, it's a little more straight on. Right about 100, a little over 100 watts out. So, I don't think the tubes are dead. You know, this thing was like 0 output on 10 meters. So, I'm going to go ahead and move up to 10 meters. Let's see if we can peak our pre-select. So I'm going to rotate around to the 10 meter area. Okay, that's got the pre-select set. I'm going to move the plate over to the 10. I'm going to put the loading back up about 4 to start with. Turning the carrier all the way down. Checking the idle bias. We're still at 60. That's good. I'm going to turn this down. This thing had literally no output. Wouldn't even flicker the needle before. So I don't know if it's going to work now. Seems like 10 meters and FT101s here lately are an interesting combination. So let's see if I can raise the current up to about 100. It is coming up some, but not much. We do have very little output there. That's basically max carrier. So I'm going to see if I can dip the plate just a little bit right there. Just ever so slightly. See if I can increase the output any. It looks like about max on the pre-select. Let's try the loading. It's pretty close right there. And plate. Yeah, okay, so we still got some problems on 10 meters. That might be just the radio needs an alignment. If you remember on the last 101, I didn't go through the alignment on it, but I did do the alignment on it, and that one was only putting out like 2 watts on 10 meters. This is on position 10A, which is about the same as what we had on that other 101. This one's got maybe just over a watt output. The other one was roughly kind of the same, and an alignment brought that right up. So, yeah, I think this one probably needs an alignment as well. I think that's kind of be the next step, and by kind of I mean I really want to change some other components in this radio first before we do the alignment. I think the tubes are okay. 100 watts out on 40 meters, no problem. And I didn't even have the carrier turned up all the way. I just took it up to 200 milliamps on the cathode current, and it was putting out 100 watts. So I think the tubes are probably in good shape. But one thing I do want to do is make sure this thing is neutralized better. So I think it probably needs that other capacitor change, just because, like I said before, the variable cap is completely unmeshed, which means they're at a limit of tuning the neutralization. I'm not sure that actually brought it down all the way. These are American tubes. I'm thinking it needs the other capacitor. So I think we need to change that. There's those caps that I mentioned on the regulator board in the last video. I think will probably be important to change those, especially since one is bulging. This is going to vary some things. If I change those caps out, things are going to change in the radio. So I definitely want to make sure that, let's get it in the condition it's going to be in order to align it. I don't want to align the radio, change the components, and that change things in the radio itself, and then basically have to redo the whole alignment over again. So I think we're definitely making progress here. We have IC reading now. We have output, so I think the tubes are okay. We'll see if they neutralize okay. Tubes aren't cheap, so I think let's narrow everything else out before we decide, hey, we need to get new tubes. If we can get it neutralized right, even though those two tubes do have a little bit different construction to them, if we can get it neutralized, then I think we're okay as far as the neutralization. But I think we're going to need that other cap. We're also going to need to obviously change those regulator filter caps. And I think it'd probably be a good idea to make sure that we're in good shape on C13. Like I said, right now it's got two capacitors in series, which I have a feeling they probably did that in order to get the voltage. But that I think it'd be better to just have one cap that's overrated to at least 1.5 kilovolt, maybe 2 to 3 kilovolt. That's going to make that cap last longer in that very high heat environment. If you remember, there's those two very big resistors right there in basically the same compartment as that capacitor, which can make, that's a pretty hot environment to operate in. So we definitely want to make sure that that's in good shape. That has been a known problem with 101s, especially when they're run pretty hot on AM. It tends to really kind of cook those caps right there. So I think that's where we're at. I think it's just order some parts, especially these caps, get them changed out, see if we can do an alignment, and see if we can get it neutralized. And then we might be in good shape, and this radio will be good to go. Just wanted to bring that to you. Like I said, I got that resistor changed out, and I really wanted to find out if, hey, can we get some IC reading now? And we do. So we're definitely making progress there. Thanks for stopping by. We're going to continue with this and see if we can't get this radio all fixed up and back to the enjoyment of its owner. Bye for now.